Well, hello everybody. I'm going to talk to you today about some Japanese trilobites and discuss their potential biogeographical significance. So firstly, I'll introduce the three terrains of Japan. And as you can see, there's not a great deal of outcrop, but there's South Kitakami terrain in the north, then the Hidagayan terrain in the centre, and the Kurosegawa terrain, which is in the south and southwest. And believe it or not, Paleozoic fossils somehow managed to survive the pressure cooker that is Japanese geology. And you can see from this figure here that this sort of typical Paleozoic marine fauna is preserved. And trilobites are an important component of these faunas. So the main aims of this project are to try and examine how these terrains are related to one another, but also to put them in a regional context and see whether they're related to China and Australia, for example. So the group of trilobites I'm going to talk to you about today are proetids. And for those of you who don't know, proetids are relatively small and basic. They've got the classic sort of trilobite shape, as you can see from this line diagram. So most importantly, proetids are the most diverse of the trilobite groups, and they're also the most diverse in Japanese rocks. As you can see here, there's over 20 species being described. And the most diverse fauna is here in the Silurian Formation with 7 species. Then there's a couple of species in the Shitoigani Limestone Formation. And then there's at least 2 species here, but there's a lot more material from private collectors that I'm hoping to be able to access. Then in the Devonian, this is the most diverse fauna here. There's at least 4 species, but I'm hoping to be able to access more. And then there's 2 species in the Nakazato Formation and 1 in the Naidai-jin. And you may notice, it's not that clear on this figure, but there's only 1 species that's shared between more than one terrain, the species up here. And other than that, the fauna show a remarkable level of intra-terrain endemism. So I want to try and work out whether this is a real biogeographical signal or whether there's something else going on. And to do that, I'll take a step back, literally, and look at the paleogeography of the region. So there's a few other trilobite groups that have been studied previously, and elenids and scutelloids from this formation have shown strong links, multiple species level links with Australia and New South Wales. And then some previous work we carried out last year on fake opid trilobites from these formations showed strong links with North China, as shown by these stars. So there's clearly there's no way that the Japanese arc here can be connected to both North China and Australia at this time. So there's clearly something else going on. And so I'll try and explain this by introducing a popular concept in marine biogeography. And basically, you have shallow marine faunas here, and they have a more widespread distribution deeper marine faunas have a more widespread distribution than shallow marine faunas that tend to be more endemic. So if we have a look at the lithofacies distribution in Japanese rocks, you can see that the majority are shallow water carbonates, but these 2 formations at the top are mudstones, which indicate a slightly deeper water environment. And this is where we find the shared species. So this suggests that there's a strong lithofacies control on the distribution of proetids, and to an extent it's overriding the biogeographical signal. It also cautions against using simple comparisons of faunas between different regions, and we need to take into account the facies ranges of each trilobite group and their ecology, and combine these in their spatial and temporal environmental context, and potentially use other groups such as ostracods and brachiopods. So thank you very much for listening. I'm happy to take one question now and chat in the break about trilobites, and I'd like to thank these people. So thank you for listening.